Hello, we'll see how to go through the recursion tree for the tic-tac-toe game we built. Okay, so here is a simplified function for the xmove function. I took some liberty to simplify it so that it's clearer here. For example, so this is the xmove is the function, and it's passed, the board is passed into it, and I'm not showing the fact that board is a two-dimensional array. This is something you know, and I'm in the beginning I am noting down, I'm checking whether if the board is full, so it means that there is no more place in the board to play anymore. So I mean all positions in the board is filled. So in that case I'm going to return draw. Okay, so this is taken care of in the program slightly differently, but so I'm going to assume this as an if condition there, and I'm going to return there. And the next, then we have this for loop which goes through each of the row and column of the tic-tac-toe board, and it's trying to fill each position with x. Okay, right. I'm going to, so a small thing I need to have here. I have just said that okay, inside the for loop we go through each of the the row and column of the board, and basically if a position is empty, it's free. So we use the fact that it's blank, so let's just use that here. So it's if that position is blank, I'm going to put x there, and I'm going to check if it's a win or not. Okay, so once we come here, down here, I need to make this. Okay, so I fill it with x, and if this is going to be a win, I'm going to return win. On the other hand, if it's not a win, I'm going to ask, basically I'm going to call the O move. Okay, so basically the opponent's move. With that board position, I'm going to call the opponent's the opponent's move, right? And it's going to return it into success. So the opponent might play somewhere and say that the opponent is going to win, or opponent is going to lose, or it's going to be a draw. So opponent is going to reply in one of these things, and that's going to be stored in success. And I'm going to change from x to blank, because I don't know whether maybe I don't have to play at this location. Maybe I'll have to change and play it in some other location. In that case, I need to change it back to blank. I change it back to blank, and then I check whether the success is a loss. If a success is a loss, this is a good move, right? Playing at x, that location is a good move, and I'm going to return win. That means I will win from that location. Otherwise, I'm going to return no. If the success is a draw, I'm going to just store that fact in the draw, that a draw is possible from this location. So I'm going to store it in some place. Earlier, this outcome is set as loss. That's the default value. If some draw was possible, I will set the outcome to draw. Okay. Now, then this for loop is going to be executed. It's going to look at all positions, and once all positions are over, it's going to return whatever the outcome is. So outcome, if somewhere a draw was possible, return outcome would be return draw. Otherwise, it's going to say that it's a loss, because I didn't see any outcome. So it's I didn't see any draw. So therefore, it will return as a loss. Good. Right, now let's see how this is, let's try to build the recursion tree to understand how this execution, how this program is going to be executed. So I'm going to start from this location. I'm not going to start from the original, from the beginning. Let's start from this location so that we can see how things get solved fast. So let's say this is the location, and this is the board position I'm going to call xmove with. Right, so xmove is called, the first if condition, this is not going to be, this is not correct because the board is not full. There are two blank places here, here and here can be played, right? And then we are going to go through each row and column. So let's say, so first we look at the 0th column, right? So we are in the 0th column, and sorry, we are in the 0th row. First we are in the 0th row, and then I'm going to go through each of the columns. So we are now here. We're basically looking at this row, right? And so first point, I can't put any, I mean, I'm not going to touch that because it's not blank, right? And then the next point is a blank. So what happens? It's a blank, and therefore we come here and I put, I set this point to x. And once that is set to x, the board checks whether is that a win. So that's not a win. Putting x here is not a win. XXO is not a win. So this is not going to be called. So it comes here. Now it's going to call OMU with this board position. So that is, after putting x here, this new board position, it's going to call the function OMU. That is the opponent player O player's move. Okay. So this is the x player's move, and then once this is done, it's going to call the O player's move. So let's draw that. So according to our tree notation, this should look like, it's coming like this, and x here and an x here, and I will just fill in the x things and then fill with red the OMUs. O is here, O is here, O is here, O is here, right? And this is the new board position with which the OMU is called, right? Yeah. So this is here, OMU is called with this. Now this position is going to be evaluated by the O player, because this is now, so the OMU function is going to be, it looks exactly like this, but it's symmetric. It basically changes. Rather than calling OMU, it's going to call XMU. So it's basically symmetric. So I'm going to keep the same function. I mean, I'm not going to write the OMU function. You should think of this as an OMU with things changed accordingly. Okay. So this now board is now called here, which is now for OMU. Okay. Maybe I can just change it to OMU. Right. This is now inside OMU. Right. And then OMU is basically, is it full? Board is full? No. It's going to look at all columns. And it says it goes through the first, the 0th row, everything is filled, so nothing happens. So, I mean, 0th row, it goes through the 0th row, 0th column, nothing happens. 0th row, first column, it's not blank. 0th row, second column, it's not blank. Then it comes to first row, row number 1. So, row 1, column 0, that position is not blank. Sorry, that position is blank. Okay, so this should have been blank. Okay. So only if this is blank we should enter. Sorry for that. So it's blank and we come here, and once we are inside, I check here, right? This is blank. So what is it you have to play? You have to play O. So this has to be O because we are now inside OMU. So this O player has to now fill it with O. Okay, and he has now basically changed the board again and filled it with O. He now comes here. Is it a win? No, it's not a win. Okay, it's not a win, and now it's going to check whether success is called with X move. Okay, symmetric. Now it's going to call success with it's going to call the function xmove with this changed board where this is also O. Now if I draw that, so once I call that, it's going to, let me draw that. So that is x, O. So O I will write later. And this is also O. This is x. This is x. So this is O, 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 O. Okay. So now this is now, So this is an X move. So we are back to X move with this new matrix. Right. Now it comes here, can X move, it comes here and the board is full. So what will this return? This, now the X move is going to return draw, right? Okay. And now, so we are back to X moves board position. Sorry, O moves board position. So we are back to this function now again. So O move had tried to play here and it's resulted in a draw, right? And then, so that means its success is now set to draw, right? Because so success is draw because it got return as draw, and therefore outcome also becomes draw, right? And then it tries to fill in, it tries to see whether is there any other position to place the O, and there is no more position, right? And therefore the entire for loop gets executed and it comes here and it's going to return the outcome. What is the outcome now? Outcome is draw, right? Because when this draw came, the outcome was set to draw, and therefore this will now return draw. Right. So this will take me back to my original the original X move function, right? The first time I called this position and I used that board and called the X move function. So I have basically I've gone back there now. So I am going to go back to the X move and fill everything correctly back. I'm going to fill it back to X move. This is right. Now this is X move. And X move saw that when I filled X here, I got a return draw from O move, right? So I was here and the success is now draw. And so I set it back to blank, and its success is not lost, so I'm not going to return, and success is a draw, and therefore I'm going to take my outcome is equal to draw. I set my outcome is equal to draw. Okay. So that is when I filled X here. But my for loop is going to continue. Right now, my for loop was here. Next, it will go here. The 0th row, third column. So that is not blank. So we are not going to do anything. Then it comes here. It is blank. Okay. So I'm going to put an X there. I put an X here and I check, is it a win? Yes, it's a win. So it's going to return. So this function will return win from here. Okay. So this is how it will work here. Now, so I hope this much is clear. Okay. Now we can see another, we can look for a different board position. Now let's look at this board position, and we're going to call this board again to X move. X move sees that the board is not full and it's going to start by filling in X's in the blank position. So this it first fills that blank position and it's going to call the O move with this new change of board, right? And obviously when I put X here, it's not a win. So it's going to put X there and it's going to call the O move, the function O move with this changed board. So I'm going to draw that here. Okay. So this is the case. Now what happens? Now we are in O move. We are in O move here, and you should see now this function as an O move. It comes here, the board is not full, it goes through all the non-blank position and finally it reaches here, right? And when it reaches here, it sees that I put an O there, it's going to be a win, right? So I put an O there. Right? So if you put an O there, it's a win. So what will this function do now? It sees that it's a win and it's going to return win. So it's a win from that position. Okay. So right now Next thing is the following, that I'm here. I'm back in the xmove. I'm back in the xmove place, and I've put here. That's what happened now, and so I come back here. I come back. So this is the next place to play, right? So I'm going to play there. So if I play there, so now again I play this with the x here, and obviously with an x there is not a win, so therefore I call OMU with this new board. Now it's again back to OMU, and the board is not full, so the OMU is going to go through each of this location. It's first going to place an O here, and it places an O there, and it's not a win, so it's going to call, after placing the O there, it's going to call the function. So it's going to call xmove with after playing O there. So how will this be? Okay, now with this board, the function xmove is called. So we are in xmove. I come here inside the board, inside the for loops, and then I'm looking for a blank position, and I find that there is a blank here. So I put x there, and I see that it's a win, right? So the xmove finds that it's a win, and it's going to return a win. Right? So I'm going to mark this. This is an x win, right? And this is an O win. Okay, just for us to understand. Now, so it has come to this board. We reached this board when O player played at this location and called the expression. Right now, to play this, this is not good for the O player, right? Because X player has returned with a win. So O player is going to play a new position. It will check for a new position to play, and it will find that it can play here. O move will play there, and it will play O there and see that, okay, this is a win because of this. There's a diagonal win there. So it will see that it's a win, and therefore it will now reply that it's a win. What win is this? This is an O win. Right? So this is an O. So both these locations. So whenever, okay. So it's a win for O, and then the xmove function which called sees that it's a win if I play x here. If I play x here, it's a win for O. So X player realized that I can't play here or I can't play here. Both are a win, so it has to play there, right? And now what can it do? It's going to see both these locations, then it's going to come to the third location. It plays here. Once it plays here, it plays X there and sees that it's a board. It's a win it's a win, and it's going to return win. It's clear? Okay. Yeah. So because it returns win, it's an X win here, right? Because it plays X there and it's a win. So few things you can notice is that this is xmove's board position. When xmove gets the board, it's like this. All at this level. This next level is basically O's board position, and the level below is again X. So there is an alternation. First X, then O, then X, then O. It will be like that. And the next thing you can notice is that all the leaf nodes are basically the base cases. Why is this a base case? Because it's a win. It's returning from win here. And why is this a base case? It's returning from win here. So these are base cases, right? Okay, so I hope you got an idea of how how recursion works, and how to view this recursive setting. Okay. So if you had more positions to play, obviously there are going to be more number of these are called children for this node. The more number of children for this node, and also it could have gone more and more deeper, right? Because if there are more moves to play, then next move will be played by O, and then the further down it will be played by X, and it will keep on going. So, so you can take a board position like this and then try to work out what will happen. You can try to draw a tree, take a board position and try and start with the board position and try to draw a tree by while going through this board. Okay, and that's good. Thank you.